Very good morning to all. In the last lecture, we have solved one numerical related to the singular transformation, and in that we have derived the CZ loop, right? So, loop impedance matrix we have derived, whereas we have already said that in the singular transformation technique, we have three types of matrices that are to be formed. The first matrix was uh, bus admittance matrix. Just a quick recap of the formulas that we have written. So we have written this as Y bus is equal to A transpose Y A. This was the first formula that we have written. Then the second formula was related to the branch admittance matrix. So YBR is equal to B transpose YB. And the third formula that we had seen in the singular transformation technique was Z loop is equal to C transpose ZC. So these were the three set of formulas which we have written, which are to be calculated in the singular transformation. So this is what we understand by the singular transformation technique. Out of this, we have solved the last one, that is Z loop, in the previous numerical. So in the previous numerical, you all have calculated the Z loop. We will just check the answers of the Z loop. Let us check it. So this was the answer that we have calculated in the previous lecture. I hope this is cross-checked by everyone. If there is any discrepancy, please let me know so that we can cross-check the figures which we have obtained from here. Okay. So now the task is to, even though in the numerical they have not asked us the other two matrices, that is the um, admittance matrix and the branch admittance matrix. So bus admittance matrix and the branch admittance matrix, these two are not asked in this particular problem, but we will solve the other two matrices also, because we want to know how these other two matrices will be solved. So in the question paper, it will be given which matrix is to be calculated. If they have asked you to calculate the Z loop, then you all know we have already calculated this by using the formula Z loop is equal to C transpose ZC. C transpose ZC, this was the formula which we have used in the previous numerical, out of which this C we all know how to calculate. So C is nothing but the basic loop incidence matrix. Then this small z, that is the primitive impedance matrix. This we have already solved in the previous numerical in this way, and we have already calculated all these matrices first, and then we were able to solve the problem accordingly. Now what we will do here is we will solve the problem for the other two parts. What are the other two parts? The other two parts are the Y bus is equal to A transpose YA, YBR is equal to B transpose YB. The second part will be quickly solved because we have already calculated the B matrix. So if we have B matrix available with us, we can quickly calculate this YBR. But let us go with the sequence. In the sequence, we have Y bus first, that is A transpose YA, and then YBR, and then Z loop. So in this problem, Z loop was asked, so that's why we have calculated Z loop. Now the previous problem is over with the Z loop itself. Now let us calculate the other two. So this problem is over here. So all of you were supposed to calculate this and check this. I have given the solution. So if there is any discrepancy, please let me know. If you have solved this, then you will be able to reply here. Otherwise, I don't think anyone will be able to reply over here. So let us go back and first check the A matrix. So whether we have worked out A matrix here, can anyone reply? Whether A matrix is worked out by us? If we have worked out the A matrix, then it will be easy for us to calculate the YBus. So I don't think we have worked out the A matrix. So we need to work out the A matrix. So can anyone reply on the chat box whether we have calculated A or not? What is A? A is bus incidence matrix, right? So have we calculated bus incidence matrix? Anyone can reply? If you have all the solutions in your copy, please check it out and check whether we have calculated A matrix or not. If not, then we have to calculate A matrix first. Then only we will be able to work out the YBus and YBR. So YBus and YBR I will calculate, and this will complete our unit number 1, because this is the second part of our unit number 1. So today we are going to complete with the unit number 1. You have to practice lot of variety of problems from the question bank. You can take variety of problems. The question papers are already available. Okay, so can anyone reply? Have we uh, calculated A matrix? I think we have not calculated A matrix. Anyone please reply fast, because B we have calculated. We know that B we have calculated here. Just let me show. So this is the B matrix we have already calculated, but I don't think we have worked out A matrix. Anyone please go through your copy and fast reply whether we have calculated A or not. If we have not, then we have to work out A matrix first in order to calculate the YBus. Yes, quick reply. In the previous problem, have we worked out A matrix? Shall I call the name of the students? Okay, someone has replied. Yogeshwari. Okay, so we have not worked out A matrix. So we need to work out A matrix first, and then only we will be able to calculate YBus, right? So why is it so? Because the requirement of the YBus is A transpose YA. So you will see the formula here for YBus. It is A transpose YA. So if it is A transpose YA, that means we require A first. Then we will see what is Y and how it is to be worked out. So the basic requirement here is to work out the A matrix first. Then only we will be able to work out the YBus. So let us first write the A matrix. So for that we require, for this what we require is, we require this graph or tree co-tree. So we will put it here. So this is our graph here. So just let me draw it once again. Zero, 1, 4, 2, and 3. These two are links. So this will be drawn by the dotted lines. Don't forget to cross check the directions, because if the directions will become wrong, then your entire solution may become wrong. So just cross check the directions whether it is okay or not. Yes. So let us now put the name of the element. So this is 1, 2, 3, 4, 5 and 6. This is also very important because if you will, sorry, 5 and 6 has replaced, so we need to change it. So this one is 5 and this one is 6. So if you will replace the position of the elements by your own, then your answer may become wrong, right? So please don't do that, otherwise your answer will be wrong. So please put all the things which are as it is given in the numerical. If it is not given, then we have already replied what is to be done, right? So if the directions of the elements are not given, then we have already stated what is to be done. We have to go from lower node to the higher node. Similarly, if we want to put the numbers to the elements, then please try to put the numbers branches the same number, that is in the sequence 1 2 3 4 5 accordingly, and the last element should be branches. So try to keep it like that. If not, then it's your choice. You can put the number to the elements as per your choice and choose the branches and the link according to the conditions. We have already stated what is the conditions. The first condition is all the nodes should be present. The second condition is that there should be no closed path while choosing branches. And once you choose the branches, the remaining elements will be automatically links. So this thumb rule you have to apply. And after applying this thumb rule, if you have chosen the first elements as the branches and next element as the link, then you will be able to write the matrix very easily. But if the elements are jumbled, like in between some of the element are branches and some of the element are linked, then you have to write your matrix accordingly. We have taken one numerical related to that, so you have to follow accordingly. So now let us first write the A matrix. So we will write here A matrix. So we all know what is A matrix. A matrix is the bus incidence matrix, and while writing this, we are going to write first elements here, and we are able to write all these elements in sequence because we have considered the first four elements as the branches and second two elements as the links. So 1, 2, 3 and 4 are branches, 5 and 6 is link. Then we have to write here the physical buses. Physical buses means in the numerical, the physical buses are those buses which are given number and a circle. 0 is not a physical bus because this is a reference node. So 0 is always a reference. That's why we never consider this reference when we write the A matrix. So here we have to write only the physical buses which starts with a number and a circle around it. So 1, 2, 3 and 4. So these are the four buses, physical buses which were present in the numerical. So we have to write all these four buses accordingly and then start filling the columns one by one. Or else what you can do is you can write the element node incidence matrix first and then eliminate the 0 column and again rewrite the matrix that will give you the bus incidence matrix A. Okay. So let us start filling the columns. So first we will fill the column 1. So for this we have to go to node 1. Node 1, the incoming and outgoing we have to cross check. Outgoing will be always positive, incoming will be always negative. So outgoing here is 2, so I will make here 2 positive, and 1 and 5 is incoming, so I will put 1 and 5 as -1. Then for second column, that is node number 2, we have to go to node number 2 and check the incoming and outgoing. So incoming and outgoing, let us check. So incoming is 2, outgoing is 3. So incoming will be negative and outgoing will be positive. Then column number 3. So this is column number 3. We have to go to node number 3. So in node number 3, both are incoming, 3 as well as 6. So 3 as well as 6, both will be -1. And for fourth column, we have to go to node number 4. Node number 4, we have 5 and 6 as outgoing. So we will put 5 and 6 as positive, and 4 is incoming. So we will put 4 as -1. Rest all the entries will be 0. Is that clear, everyone? And here there is no question of cross checking the things, because we used to cross check the element node incidence matrix by all the summation of individual rows should be equal to 0, but this we cannot apply here. But yes, if you want to cross check that whether the part which you have written here is correct or not, what you can do is you can just add the reference node 0 in this way by using pencil, and then you may rub it. Okay, so let me write here 0 column. So in 0 column 1 and 4 is outgoing, so 1 and 4 I will put +1, rest all will be 0. So now cross check whether all the summation of each rows is 0 or not. So -1 minus +1 0, 1 minus 1 0, 1 minus 1 0, then -1 +1 0, then -1 1 0, -1 1 0. That means whatever you have put here is correct. So you need not write this part. I have just written here to cross check it. Okay, so don't write this. I have just written it only to cross check it whether the bus incidence matrix which we have written is correct or not. So you can write it with a pencil and just erase it, because it's required only to cross check whether the bus incidence matrix which you have written is correct or not. So I have just inserted it and I'm just removing it by erasing the 0 reference column. So is that clear, everyone? A is okay. So A is done. Now what is the requirement now? So A is done. So in order to find this, in order to make this YBus, what is now required? The required is Y. So if Z we know, then it is easy for us to know Y, because you know that Y is admittance, and admittance is always the inverse of the impedance, right? So impedance, we know that impedance and admittance both are related with each other. If we know impedance, we can find admittance. If we know admittance, we can find impedance. So vice versa. So now what is the requirement? So in this formula, that is YBus is equal to A transpose YA. What is the requirement now? Because we have right now got A. So if we know A transpose is automatically known, right? Because we need to just interchange the rows and columns and we will get the A transpose. Now we are left over with Y. So we need to calculate Y first now. Okay. So in order to calculate this Y, what is to be done? Let us write the self-impedance values which was given in the problem. So the values were in this way: 0.1, 0.1, then 0.43, 0.2, 0.22, 0.3. So we have to write all these impedance values which was given in the problem accordingly, and then we need to solve it. So let me write here the values. So one is having because then only we will be able to write the Y matrix. So this is 0.1, fourth element is also 0.1, then this element is 0.3. This was already provided in the numerical. Don't worry, this will be provided. You have to just enter this. So then 0.43, this is 0.43, then 0.2 and 0.22. So 0.2 and 0.22. So this was the value which was given to us, the self-impedance values of all the elements. Now for calculating Y, it's very easy to calculate the self-admittance matrix. So if Z is the self-impedance matrix, this is self-admittance matrix. So how do we calculate? Let us see this matrix. So as we all know that we are going to follow the singular transformation technique. So in this singular transformation technique, what is done is, in the singular transformation technique, only the self-impedances are considered. The mutual impedances are not considered in the singular transformation technique. So in this singular transformation technique, we only fill the diagonal elements. The off diagonal elements are always taken as 0. So when we take this y, what we do here is, again this y will be also a element by element matrix, because Z was also a element by element matrix. So this will be also a element by element matrix. And as in this problem we are having 6 elements, so this will be also a 6 by 6 matrix. And we need to only fill the diagonal part, that is y11, y22, y33, y44, y55 and y66. Rest of all the elements will be 0. I will just write here. If you will have any point to understand, I will just explain you. So I am just writing the values in this way. So as this is a 6 by 6 matrix, the values will be in this way: y11, y12, y13, y14, y15 and y16. Then the second row will be y21, y22, y23, y24, y25, y26. Then y31, y32, y33, y34, y35, y36. Then y41, y42, y43, y44, y45, y46. Then y51, y52, y53, y54, y55, y56. This is 5. And similarly the last row will be y61, y62, y63, y64, y65 and y66. So this is the complete structure of the Y matrix. So the Y matrix will have this type of shape. Now here, as we are following the singular transformation technique. So what does the singular transformation technique states? Let us understand. Singular transformation technique states that we have to take only the diagonal elements. Why? Because we are considering only the self impedances of this complete system. So if we are taking the self impedances, then only this will have the non-zero values which will be taken from the problem, and the upper triangle and the lower triangular matrix, that is the off diagonal matrix. So this is your upper triangular matrix, this one, and this is the lower triangular matrix. So this upper triangular and the lower triangular matrix, this will be always 0. So all the elements related to this will be 0. You have to just insert the values in the diagonal part, that is y11, y22, y33, y44, y55 and y66. In the same way in which you have taken the values in the previous part, that is C transpose ZC. In C transpose ZC, what you did was you simply inserted these values in the diagonal part. That is, in place of this y1 z, in that case it was z. So z11, z22, z33, z44, z55 and z66. So z11 will be 0.1, z22 will be 0.2, z33 will be 0.22, z44 will be 0.4, z55 will be 0.43 and z66 will be 0.3. All these values are corresponding to their respective elements in the tree and cotree which you have drawn previously. So in the tree cotree you have to identify where is the location of that particular element and you have to write the values accordingly. So that was related to Z. But when we take Y, you know that for Y we need to make the inverse of the entire matrix. That is, if Z is 6 by 6 matrix, then the inverse of that matrix will be Y. But here you also know one thing, that only the diagonal part is having non-zero term. Rest of all the values, that is upper triangular and lower triangular, is replaced by 0. So in such a case, it's easy for us to calculate the inverse of that matrix. Okay, so I will just go back to this particular matrix where we have calculated the Z. So this is the Z portion, right? So here in this Z portion, you have all these values in the diagonal part: 0 0.1, 0 0.2, 0 0.22, then 0 0.1, 0 0.43, 0 0.3, right? So what you have to do here to find Y? To find Y, you have to take the inverse of this matrix, right? And inverse of such a matrix is very simple, because see, upper triangular is 0, lower triangular is 0. So 0 inverse will be 0 itself. Now you have the values only in the diagonal part. So for this you have to make the reciprocal of these values. So this is the concept of mathematics which we implement whenever we need to find the inverse of such type of matrix, where only the diagonal elements are having non-zero values, and the upper triangular and the lower triangular is having 0 values. So that's why in our syllabus the university has given us singular transformation only, because if we would have taken the mutual impedance, then all these values also would have been replaced by some other values. So if non-zero values, so if these values are replaced by non-zero values, then you have to make use of the mathematics where you have solved the inverse by partitioning the matrix, and there were various techniques which you have learned in I suppose mathematics 3, if I'm not wrong. So have you all learned matrices in applied mathematics 3 in your third semester? So do you all remember, in matrices you have done so many operations, out of which inverse was one of the operation? Can anyone reply? Yes, fast. So I hope you all remember, because everyone has reached now to 8th semester, but third semester is not to be forgotten, right? So if you forgot this third semester, then this unit will be very difficult for you to understand. Yes, have you all learned the operations of matrices in applied mathematics 3? Anyone can reply, provided you remember what you have learned in mathematics 3. No one? No one remembers what you have learned in mathematics 3? Okay, no problem. So what we have to now do is we have to find the inverse of this particular matrix Z. So it's easy for us to take the inverse of this matrix Z. How? By simply making these values reciprocal, because the upper triangular and lower triangular matrix values are 0. So only diagonal elements are having non-zero terms. So what we will do, we will just make reciprocal of this, and we will find out the Y matrix. Okay. So let us write the Y matrix. From where this point 1 has come here, let us check here. Okay, so point 1 is the value, because, so let me correct here, this fourth element is point 1. So this is point 1. Okay, So what we will do here now, we will make this Y matrix. So let us make the Y matrix. So Y matrix will be equal to first element. What is first element? Let us check. First element is 0.1. So zero point 0.1, as it is the value given in impedance, we have to make it inverse. So 1 by zero point 0.1. Then all the values will be 0. 0, 0, 0, 0. So 1, 2, 3, 4, 5, 6. So 6 by 6 will be our matrix. So second, let us see what is the value. Element number 2. So for second, you will have to go to this element number 2. Element number 2 is having 0.2. So what we will do here? We will simply make it reciprocal, that is 1 by 0.2. Then third element is 0.22. So we will make the third element as 1 by 0.22. What about fourth one? Fourth is 0.1 again. So 0.1 means again 1 by zero point 0.1. Then fifth is 0.43. So we will have to make 1 by 0.43. What about sixth? Sixth is 0.3. So we will have to make 1 by zero point 0.3. Rest of all the values we have to put 0. So as these are the off diagonal elements, so this will be 0. We will just enlarge this because then it will be easy for us to write this matrix. Okay. So 1, then we have to insert 6 zeros. 5 zeros, sorry. 1, 2, 3, 4, 5, 6. Then 0, 0, 0, 0. Then 0, 0, third element. Then fourth, fifth, sixth. Then 0, 0, 0, fourth element. Then fifth element and sixth element. Then 0, 0, 0, 0, fifth element. Then sixth element. Then 0, 0, 0, 0, 0, sixth element. So in this way we have completed our Y matrix. So can you all calculate and reply me what will be the values? Y11. Reply on the chat box. 1 by zero point 0.1. What will be the value? This value, 1 by zero point 0.1. Yes, quickly reply on the chat box. Yes, quickly reply on the chat box. What will be 1 by zero point 0.1? Yes, so first value will be 10, 0, 0, 0, 0, 0. Next, second row, 1 by zero point 0.2. What will be the value of 1 by zero point 0.2? 5. 0, 0, 0, 0. Next, third row, 1 by zero point 0.22. 1 by zero point 0.22. 4.54. Is it correct? Next, fourth row, 10. We have already calculated it. Fifth row, 1 by zero point 0.43. What is the value of 1 by zero point 0.43? 2.32. And last, 1 by zero point 0.3. 3.33. So this is your matrix Y. Now see, everything is available with you. You have A, you have Y. Now what is the formula? Formula is Y bus is equal to A transpose Y A. So insert all these values and quickly reply what will be the answer. So we have already A available with us. What is A? This is the A matrix which is available with you. So you have to make the transpose of this and make the rows into column. Right? So I will write the answers in this way. So -1 0 0 0. This will be my first column. So let me write here Y bus is equal to -1 0 0 0. This is the transpose of A matrix I am writing here. Then minus 1 -1 0 0. 1 -1 0 0. Then 0 1 -1 0. 0 1 -1 0. Then 0 0 0 -1. 0 0 -1 0 0 1. Then 0 0 -1 1. 0 0 -1 1. So this is your A transpose matrix. Then you have to write Y matrix, which you have calculated right now. Okay. So what is your Y matrix? Let us check. This is your Y matrix. 10, 5, 4.54, 10, 2.32, 3.3. So let me write here 10, 0, 0, 0, 0, 0, 5, 0, 0, 0, 1, 1 more. Then 0, 0, 4.54, 0, 0, 0. Then 0, 0, 0, 10, 0, 0. Then 0, 0, 0, 0, 2.32, 0. And finally 0, 0, 0, 0, 0, 3.33. Then multiplied by A matrix. So A transpose I have already written here. So based on this A transpose, I will write A here. So I'm going to write A here as there is no space there. So I'm writing in the lower portion. So if any matrix you are inserting in a wrong way, you will get the wrong result. So please ensure that whatever you are writing, it should be correct. If there is any mistake, then your entire answer will become wrong. So don't do such mistakes. Otherwise, the entire things will become wrong. So I will copy it from the A matrix itself. -1 0 0 0, -1 0 0, then 1 -1 1 -1 then 0, 1, minus 1, 0, 0, 1, minus 1, 0, then 0, 0, 0, minus 1, 0, 0, 0, minus 1, then minus 1, 0, 0, 1, minus 1, 0, 0, 1, then 0, 0, minus 1, 1, 0, 0, minus 1, 1. So this is your matrix A. Now your job is to multiply this and find out the results. So let's see who finds it out quickly. So I will put here equal to. So this is your A transpose. This is your Y and this is A. So multiply first A transpose with Y and then the product will with A. So let's see whose answer comes first. So please quickly find it out answers. A transpose Y A. Similarly, you have to find out YBR. The formula is B transpose YB. So this is for YBus. YBus formula is A transpose YA. So whatever is there on your screen, with the help of that, you can solve the YBus part. So after this YBus part, you have to calculate YBR part. In some problems, YBus, YBR and Z loop, all the three part is asked. Even in the MCQ part also, they may ask such type of question and they may give you 4 alternatives. So first you have to calculate all the things and then mark the alternatives. So if you will calculate all the things, then only you will be able to mark the things in the MCQ, right? So I presume that you all know how to multiply the matrices, right? I have already stated this in the very beginning of the CAPS lectures, that in this unit you will be requiring the help of matrix multiplication. So be conversant with that matrix multiplication and solve accordingly, right? So we will check the answers of this in tomorrow's lecture. Tomorrow we are going to start with our unit number 2. 1 is completed here. It's not possible for us to take more problems because then we will be able to complete only few units. So if you all want to complete all the 6 units, then we have to take limited numericals. So I have taken almost all the types of numerical, and rest of all the things will be shared in the notes of the unit in the Google Classroom, right? So I am expecting this results tomorrow. So tomorrow when you will join, you have to first give me the results of your YBus as well as YBR. So YBR is a homework for you. YBus, half of the portion I have solved for you. Only you have to multiply this matrix and give the answer of this YBus. Okay.